Thank you very much, Mr. Chairman. And yeah, I have been in the community, I would say, because I am basically a research guy, but I do appreciate a lot all the opportunities I have got to work together with industry in my research. I think it has been very valuable. And actually, this is definitely also the case for the work here I'm going to present here about standardization, where we have worked. I have worked very closely with very competent people in industry and in grid operation. There is a paper also here, and it's done together with my colleague Ömer Göksu and also Jens Fortmann, who was already mentioned, has been very active in this working group. Francisco from Gamesa and also Ana Morales from the Silent are co-authors here. But the first question is, why actually bother about these generic models? Because actually the manufacturers are the ones that knows the wind turbine best, so why not just let them supply their models to the system operators? And I'm trying to illustrate this here. We have system operators that actually use different power system simulation tools. And the thing is, we also have a lot of plant vendors, and they have to essentially, because this business is becoming international, and they have to work on an international market, meaning that they need to supply valid models to all those softwares as it is of today. And then the responsibility for doing that, it actually sits with the plant vendors. And the thing is that there is actually quite a lot of work involved in this. The idea of generic models is not that new, but there has been some, maybe some manufacturers have think they had a competitive advantage, but today there is a general agreement, a very strong general agreement among the manufacturers that something needs to be done about this. Another aspect actually, which we heard about a little earlier in the Silent presentation this morning, is that system operators are also exchanging information about their the grids, the states, and the dynamic models. And since they are using different softwares, there's also a place here. And this really motivates us for having an international standard for generic models, where the software vendors can then are then actually responsible for implementing the models, as you can see here. So this is making the communication easier, because we are not really communicating the model because everybody shares that. It's in the standard. What we communicate is, for this individual plants, for the individual turbines, is the parameters which can be communicated in a table. So scope of the models is there are of course a lot of modeling in wind integration, but this is in that context actually a quite narrow scope that we have of those particular models. It's about short-term stability, and we try and plug it into where the models are usable here in this. In this internationally recognized definition of the different stabilities. So it's focused on short-term stability issues, and it's not including harmonics and a lot of other things, the variability of wind and so on. It's a short-term scale. It was already mentioned a couple of times who are actually the users of the standard. So TSO, the grid operators are. Oh, I went to pushed the wrong button. Sorry. Wind turbine manufacturers are deeply involved. Plant owners, they sit between the wind turbine manufacturers and the TSOs, but they have of course a strong business involvement in this. And then the software vendors also, and certification bodies are also very interested in this, especially in Europe, and particularly in Germany, where there is a lot of focus on certification, also in Denmark. But then also from research and education community where I come from, it's actually good to have these reference models that we can base it on. So status is that we issued the first standard in 2015, or the first edition in 2015, and that one was about wind turbine modeling and also validation. Saki, he already said that there were these two aspects, the validation and the modeling. And then the idea was that we should have a part 2, which would be about the wind power plants. But when we started the work on the wind power plant standard, we realized that it was actually more logical to change the structure. And we were after, in the IEC system, you need approval for those things and it takes time and so on. But we were, there are good reasons to say that instead of that, it's much better to have one standard for the models and one standard for the validation to avoid a lot of overlap in the standards. So we went down that path, but the only cost here is that we actually have to issue them at the same time, the 2 new parts, because they are replacing an existing standard. So. But it was also mentioned earlier, also in the previous session by Dick Silent, that we are applying this modular structure, and it supports revisions, and it also supports actually, and we are trying to take even more advantage of that. It supports that we can share module specifications. In different parts of the model. I'll come a little more back to that. But the original structure, it looked like this. This is the one that is published, so this is one that applies now. You've seen it before. Actually, the structure we are working on has expanded a little, but essentially it's the same, because what we have here marked is what was we distinguish between the pitch and the generator control, which is quite natural also for the understanding and the control block, especially of the modern Type 4 and 3 turbines. It's a very huge part of this model, so we try and detail it a little more. And then another thing we do is that we share modules that are doing measurements, because we are doing measurement for protection, we are doing measurement for control in the wind turbine, and actually also for the plant control. So I have 3 different descriptions of measurement, grid measurement blocks. So that's the idea here. Of course, the parameters can still and are different, but they refer to the same model. We have done some other changes in the new or in the future standard that will be published in a little more than a year from now, we expect. But what we are aiming at making it backwards compatible. Maybe the most significant thing is that we actually included the high voltage right-through function in the new models. And then in the new turbine models, but then we have focused on the plant models in the next edition. And this gives an overview of the idea. So what you can see is that the heart of the plant model is the control. So this is the wind farm controller that we have here, and then it consists of wind turbine models, a wind turbine model, and then we have also a collection grid model here, or a collection system model here. And the thing is, it might only be including one wind turbine model, but there's also an option to have more wind turbines, or to have what we generally call power devices. So this can be a STATCOM that can be an integral part of this. So this is showing a generally showing the structure. So what we have of reference values to the wind plant model is active power, of course, and then we have one variable which is called x, but x can actually, depending on what mode we are using of the control, it can mean reactive power, it can mean power factor, or it can mean voltage. It of course can only mean one thing in one simulation, so we are not changing simulation modes during the simulation. If we look at the turbine models, it's the same, that they support active power control and also reactive power or voltage control at the terminals of the turbines. So that's not new compared to the published standard. So this is the control and communication model, the substructure of that one. And what I want to say here is that we have it basically consists of the P control and the Q control. So and then we also have are sharing models for communication. And as you can see, actually the same communication model is used 3 times. The operator is communicating the reference here, and we also have communication of grid measurements, and finally we have a communication model which is sending the reference value to the turbines. It was also already mentioned that by Zakia that there is a need for aggregation, and the standard actually prescribes the methodology can be used to do that aggregation. So the idea is that it's really up to the user how many wind turbines he wants to have in the model, but you can, depending on the structure of the specific wind plant, you can have different solutions. But by far the most common will be to have this simple representation of a wind plant with the same wind turbines, and then replace the detailed model with an aggregation. The work here is actually it was following up, you can say, on work that was already initiated in US, first in an IEEE working group, and then now in as part of the WEC working group, This WEC working group has developed the second generation actually of the models which were done in very close collaboration with the IEC working group, and we had a substantial overlap in the members also of the two working group. So we can say that the models are very similar, but there are also some differences, and I believe that in general you can say that IEC models are slightly more complexible because they have been pulled a little more towards the more demanding European requirements for model accuracy, and this is something that the manufacturers selling in Europe, they struggle with as part of the certification. So, but we are trying to make the models compatible, and I have a slide here that is showing that we actually did some comparison of the two models. So that's an interesting paper, but for the details I will just refer to that. We also have a link to the exchange of standards in the SIM There's an IEC Technical Committee 57 that deals with communication of data between TSOs. And there is already a standard for static data, so snapshots of the power systems, how to exchange that. And there is also some NSOE initiative, which has also been mentioned earlier. Now, the thing is that I heard the rumors that this standard is actually out. I tried to find it right now, but when it is very close to be published. It has been approved, says what I hear, but it's not published yet. The standard IEC for dynamic models, and the thing is that this IEC standard for exchange of dynamic models between the TSOs. It's based on available standard models like the IEC working standard I'm now talking about, and it actually uses for the wind turbines. It uses our standard here. So this is of course good for the dissemination of those general wind plant models, and it has dynamic models. I forget to say, of course, of other plants as well. On the model validation is very important. One thing is to do it at the turbine level, and this has been done, and we also published a paper making comparisons here at the turbine level based on standard tests that you actually do on wind turbines, where you create a short circuit like shown in the diagram here. Another validation thing, I know Nick Miller will also show some good examples of validation of the models. We were happy in DTU to have the opportunity to get measurements from a plant in France in the point of connection, and there we identified a change in power factor reference, and we used that to do validation work. And as you see here, that actually gave a quite good match. So this is essentially only validating that part of the model, which is about the power factor control, but that part is very well matching here. There is actually a small error if we look at the details, and that's because we are not modeling the entire grid with all the fluctuations and so on we have in the grid, but we have this constant voltage source looking into an impedance to model the grid. But instead of that, we can play back. This is another approach which is also described in the standard. If we play back, meaning we put the measured voltage in the point of connection of the wind plant, we put that into the simulation instead of this grid model, and then we get a much better performance. So I hear the bell is ringing. So, but I'm finished. But I want to my last slide is listing. We have had many members. Some of them have not been very active, but the members I list here are the ones we have that has participated in our meetings. So yes, that's it. Thank you.